Firstly, this can be a very good foundation to understand binomial distribution. Also, it can be a 2-mark question in your exam. See, first of all, to understand if that is a binomial distribution or not, what we have to do is you need to check all these 4 conditions. There are 4 conditions given. One is we need to see if there are fixed number of trials, and if we need to see if there are only 2 possible outcomes, and we need to see uh, trials are independent to each other, and if there is constant probability of success. So 2 outcomes. So as in there should be success and failure. When we do this example, then it should be much clear. So dice with replacement. A fair 6-sided die is rolled 15 times. X is a number of times a 6 appears. Number of times, see, every time they are doing the same experiment, remember. So you will have probability for one event, and if you do the same experiment for multiple times, the same thing, out of that, if you choose the number of successes out of all the experiments, then it becomes binomial distribution. So for example here, um, it there is fixed number of trials because there are 15 number of trials. So this is done, and number of here the success in each trial is getting a 6. The success can be getting a 4. The success can also be getting at least 2 on dice. So you calculate probability for that success. In this question, success is getting a 6. Probability of getting a 6 is 1 divided by 6. Given in any time you roll, any number of times you roll, each time probability of getting 6 is 1 divided by 6. So, and there are only 2 possible outcomes, either 1 by 6, not getting 1 by 6. Success is 1 by 6, not getting 1 by 6 is failure. And independent trials, it doesn't matter how many times you throw, every time getting 6, probability is 1 divided by 6. Constant probability of success. So it is binomial distribution. You need to write there are fixed number of trials. There are 2 possible outcomes. There are only 2 possible outcomes. And you need to tell trials are independent. At least if you write 2 of these, you will get 2 marks. And the next one, counters replacement example. A bag contains 6 red balls and 4 blue containers. 6 red and 4 blue. 3 counters are taken without replacement. 3 counters are taken. So we take 3 lines here. If 3 counters are taken, and we need to see this variable. Remember, this variable is going to be everything in your binomial distribution. If you understand that, you can solve almost all the questions. At least you can understand all the questions. Even if you can't solve, you can understand the questions and then you can get some points out of the question. However, if you understand this, you can solve all the questions. Y is the number of counters obtained. That tells you what you are looking for, what probability you are looking for, what success you are looking for. So Y is number of red counters obtained. So we are looking for probability of getting red counter in each experiment. So each line represents each time you are doing the same thing. When you do it for the first time, probability of getting red is 6 divided by 10. We have to see if this probability is consistent across every experiment. And for the second time, when you draw one more, when you take one more counter, probability of getting red is 5 divided by 9. So this is not binomial distribution. Binomial distribution, you need to have constant probability for all the successes. So it is it is straightforward. In other words, whenever you can see that that probability is constant every time you do, that is binomial distribution. Okay. And you would say this is not binomial distribution because probability. So this is failing this condition. The outcome of one trial is influencing second trial. So that's why this is not binomial distribution. And you have three more examples here. Pause the video now. Pause the video. You pause the video, I'm telling you 3 times. And then after that, you have solutions in the next page, which I'm going to show. These are the solutions.